So on a question like this, I do believe that using Desmos ends up being the most efficient approach. So I'll show you a few different approaches just so you feel comfortable. But let's go ahead and pull up Desmos, which is going to be in the upper right corner here in our software as well as in Bluebook. We'll click on calculator and then notice, depending on what setting you have, it'll determine how the font looks. The default is this one. So let's go ahead and take a look at that. And what I'm going to do, let me go ahead and press Control minus, kind of zoom out a little bit, maybe move this over. I'm going to zoom in actually back, but let's go ahead and type in this function as is. So I'm going to do 3x. I'm just using my keyboard. So I'm going to do the slash, that's by the question mark on the keyboard, and I'll do x plus 4. I'll go to the right, I'll press minus. If you prefer to use the keyboard that they provide, you totally can. So you can click there and it opens up the keyboard, but I kind of prefer personally doing it with my actual keyboard, but you could do it here. If you did so, you'd be doing 4x, and then when you do divided by, you're gonna put the x minus 2, and then we'll go equals -5. So our goal is to find the x-intercepts. That's the whole idea of solving, is you're finding x-intercepts. Solutions are synonymous with x-intercepts. So notice this totally looks clear, -2, and you can guess that's 5. Now to make it a little bit more convincing, we'll go ahead and put the plus sign to zoom in, and I'll just kind of drag over. So I have 5 and -2. The other thing you could do is when you click here, we'll go ahead and click on that option. To me, that's just way easier and more clear. So -2 and 5, keep in mind those are the solutions that I see. Now, another thing you could do in Desmos is instead, you could type in that left side, and then for the right side, because it's just a number, you would want to put y equals. And when you do so, you're going to put y equals -5. And notice in that case, I don't think this is as effective. However, you could find where those two graphs intersect. So when you click here, you'll see the x coordinates -2. You're always looking at the x coordinate when you're looking at the intersection. And then here it's +5. So you get the same two solutions. So just to kind of give you an idea of when I would use or implement each of those scenarios, whenever it's just a number on one side and then variables on the other, I would take the whole thing in the way that I did at first and find where it crosses the x-axis. If, however, let's go back a couple questions. If, however, you have a variable on each side, that's where I would put this left side as its own function, and then the right side as its own function, and find the x coordinates of the ordered pairs where those two functions intersect. So just to kind of give you a little bit of strategy and a distinction between those two. So let's resume looking at the fact that we did get -2 and 5, and something that's actually really nice about using Desmos is once we got our answers, we don't actually have to test either of them to exclude what we call extraneous solutions, which would occur if the denominator became 0. However, when we do it algebraically, which we're going to notice in just a moment, we do need to test for extraneous solutions. Now, if you're wondering, well, how could you have done it by hand? It's a good question. This is a little bit tedious, to be honest. If I were doing it by hand, I would go ahead and get a common denominator, which ends up being the product of the two. Even though you might be thinking, well, they have k in common, that's not really how it works. When they're binomials, if they're not identical, they're considered totally different denominators. And whenever there's a minus in between, I like to make it a plus and put that minus directly in front of the second term there. And you'll see why in a moment. But the common denominator ends up being k plus 4, k minus 2. So this first denominator over here is lacking a k minus 2. So we'd multiply top and bottom by k minus 2 there. And then this denominator over here is missing a k plus 4. So we'll multiply top and bottom by k plus 4 there. Now, if we distribute here, we get 3k squared minus 6k. If we distribute the -4k here, notice we get -4k squared, and we get -16k. A very common mistake, if people don't put that negative right in front of the 4k, they'll forget to distribute the negative to both terms. Specifically, the second term gets left behind. And then we have equal to -5. So let's go ahead and combine like terms in the numerator. And when we do so, we get -k squared minus 22k over, and let's go ahead and actually FOIL this out. So distributing, we get k squared minus 2k plus 4k, so really plus 2k, and then minus 8. All equal to -5. Now, whenever you have a fraction on one side, I like to make the other one a fraction by putting it over 1. We'll go ahead and cross multiply. and distributing that -5 makes it -5k squared minus 10k plus 40. So you're probably seeing just how much better Desmos is, but I wanted to show you this just so that you can really appreciate the fact that you can use Desmos, but also just understand the algebra here. Now keep in mind in algebra, we've talked about this quite a bit, but if you have one type of x, you get x's on one side, numbers to the other. When you instead have more than one type of x, let's say to the second power and to the first power, the strategy is you get everything equal to 0, so you can eventually factor and solve. Well, in this case, we have more than one type of k. We have to the second power and we have to the first power. So we're gonna go ahead and get everything equal to 0. And we'll do so by actually moving everything to the right, even though that would mean moving more terms. The reason I wanna do that is because I like the leading coefficient to remain positive. So we'll go ahead and add 10k. Then finally we'll subtract 40, even though there's no like term on the right side to combine it with. But that gives us 0 over here. And we get 4k squared minus 12k minus 40 all equal to 0. Now the nice thing about this one is you have a leading coefficient that is the greatest common factor, so we can go ahead and divide it out. And the only reason we can divide it out is because you can do it to both sides, since this is an equation instead of just an expression. So we end up getting 0 equals k squared minus 3k minus 10. And then we could factor and solve. We could use our program quad solver with our coefficients being 1, -3, make sure you use that negative key down here, and -10. And we end up getting 5 and -2, which we knew we were gonna get. You could instead have factored it by hand and said what two numbers multiplied to 10 have a difference of 3. That ends up being 2 and 5. One positive, one negative, with the bigger being negative. And then you could set each of those equal to 0 to get the same solutions, knowing that we always want to check back into really the denominators and ensure that neither of these solutions makes the denominator 0 and therefore the whole function undefined. Neither does so we know we get the answer as D. However, Desmos was absolutely the much more efficient approach.